Hello all, today we are covering 9.1 reflections. You guys will be able to draw reflections on and off a coordinate plane. So this first one is just kind of a preliminary idea of a reflection. This shape here is called our pre-image, that is the original one. The line I drew is our line of reflection. And the image I'm about to draw is actually just called the image. That is our new one. So notice this isn't going to be perfect. It's much easier to do it with a coordinate plane, but just gives us a heads up of what it will kind of look like. Alright, now notice the way I labeled these, that the pre-image has just A, B, and C, and the image, the new one, is labeled A prime, B prime, and C prime. That's to keep track of which one is your image and your pre-image. So that is how you should label yours too. Make sure you label every single point that you plot. So our new vocab are pre-image, image, and line of reflection. Before we go any further though, if we take a look over here, these are examples of our reflections. You can think about water reflecting what is above the surface onto the surface of the water. That is what we are going for here. That's just an example of it in real life. Alright, so reflection and a line. A reflection and a line is a function that maps a point to its image such that if the point is on the line, then the image and pre-image are the same point. You can't reflect this pre-image off of the line if it is already on it. So they are the same. If the point is not on the line is the perpendicular bisector of the segment joining the 2 points. So this is the pre-image. To find the image, it is perpendicular to the line of reflection and a congruent distance away from the line of reflection on either side. So here are more examples. Which one of these quadrilaterals is actually reflected correctly? Now, this one is just translated. Just move down, not reflected at all. This one looks closer, but I would say it's actually probably more of a rotation versus a reflection, because if you look from point to point, especially this B point, you can notice that this does not cross at 90 degrees, so it can't be that one. C though, if we look at these from pre-image C to image C, these do look like they cross at 90. It looks congruent. Check D. Pretty good. A, I think we're getting somewhere on this one. Pretty good. And B. Looks like this is probably our reflection, but let's look at D. Especially this guy here. You can tell from D pre-image to D image that this does not cross at a perpendicular. So C is our actual reflection. So how do we do this? Well, this is actually a pretty easy lesson. We mostly just need to review how to graph coordinates. So we have quadrilateral JKLM has these vertices. 2, 3 is J. Notice I'm labeling them. You must label them as well. 3, 2 is K. L is 2, negative 1. And M is 0, 1. Okay, notice I always say in my head over for X, up and down for Y. I have a college degree in math and I still say that. I also sometimes mark on top X and Y just to keep myself where I'm going correctly, okay? Now, next thing we need to review. What is X equal 1? Because that is our line of reflection that we are going to reflect over. Well, we know that X equals are always vertical lines. Okay? So x equals 1 is just a vertical line through 1. Now, how do I know that? I can check some points. I know that this coordinate is 1, 8. I know that this coordinate is 1, -2. All of the coordinates on that line always have an x value of 1. That is why x equals 1. Okay? So I have that line of reflection here. Now I just need to reflect across it. Okay? So my image, it's as easy as counting. M is 1 square away from the line of reflection. So M prime is going to be 1 square away from that as well on the other side. J is also 1 square away right here. So J prime is 1 square on the other side. Notice it's really easy when these are horizontal and vertical lines because I know that these are perpendicular to each other already, so I can simply count. There's K prime and L prime. I go ahead and draw in my image, and I am good to go on that one. Hopefully that's pretty simple for you. You just do a bunch of counting. All right. Now we're going to plot J, K, L, and M once again. So J is 2, 3. You can just follow along with me. This time we have the axis, or sorry, the line of reflection of -2, y equals that. And we know that y equals our horizontal lines. Okay? That is because this is over 1, -2. This is, oh sorry, -2. This is over 8, -2. The y's are always -2. That is why it is where it is. Okay? So from here, we can go ahead and reflect across. So this time we're counting down to this line. L is 1 box away, so we go 1 box down for L prime. K is 4 units away, so we go down 4 more for K prime. J is 5, so we come down 5 for J prime. And M is 3, so we come down 3 for M prime. And then you can just go ahead and draw in your new image quadrilateral, and that is reflected across. Okay? These next two, I'm just going to quickly go through. You can pause me. Probably not going to talk too much, other than to say make sure you label your pre-image and your image points. Know that x equals 2 is a vertical line. And then count your way across. Okay, there's that one. And lastly, follow along once again. We are going y equals -1. Horizontal line through -1. count your way. And then graph it. And there is your pre-image and image shapes. Okay? Now, instead of going through, say, y equals 2 or x equals -5 or any lines like that, we can actually also just reflect across the x or the y axis. So with the x-axis, we have this sort of equation you can use. You could also just use the counting method again. The x-axis is the horizontal axis. Notice in our equation here, the x's stay the same for the image and the pre-image. I should say pre-image and image. And the y's, though, from the pre-image to the image go to the opposite sign. So if you look here on this example, the pre-image x is 4, the image x is 4. The pre-image y is 1, the image's y is -1. The signs switch. Similar thing happens when we are reflecting in the y-axis, except this time the x's change signs and the y's stay the same. So you can use these as a reference, okay? So we have new points for a quadrilateral. We're going to plot these. So A is 1, 1. B is 3, 2. C is 4, -1. And D is 2, -3. Okay? Now we are reflecting it across the x-axis. That is this one here. To do the equation way, I like to write out my pre-image coordinates. And then I like to write out my image coordinates, marking what they are, like so. So I know when I'm flipping across the x-axis, my x's stay the same and my y's switch signs. And then I can go ahead and graph it. Now we could have just done the counting, like I said. But some of you might like having this tangible sort of equation to use. I know I don't mind having it. Gives me a reason why it works, kind of. And there is your pre-image and your image. Okay? I believe we actually use these coordinates again, so I'm actually just going to copy this down instead of rewriting it. Looks like it. And then I will graph these again. So the pre-image coordinates are 1, 1, 3, 2, 4, -1, 2, -3. Graph it. And then now we are reflecting across the y-axis. So I know my y's stay the same and my signs on my x's switch. And then I can graph these coordinates. A prime, B prime, C prime, and D prime. And that is my reflection, okay? I believe there's one more like this. I'm just gonna let you follow along. So in the y-axis, the y stayed the same, the x's switch signs. And that is our reflection in the y-axis of this one. And lastly, we have reflection in the line y equals x. This is the only one that's super crazy, and it's on a diagonal, and I would say it's probably the easiest of them all, because we have this equation. I would not use the counting method with y equals x. I would use this equation. It's so simple that you literally just put the y where x was and the x where y was. You switch the coordinate placements. Super simple. So go ahead and graph these. Now notice that is what we had been using a lot before. The line y equals x is this diagonal line from the origin with the slope of 1, 1, just like that. And we are reflecting across that now. Whoopsie. We have these same coordinates as we had before, but now we switch the x and y values. Notice a prime and a are the same thing because they are on the line. So the pre-image and the image have the same point there. And then I literally just switch my x and y's. I don't change any signs or anything. Just flip-flop them and graph them. And draw them in. So that is the reflection of that shape over the line y equals x. I believe we have one more. We'll go ahead and graph these. So this is our pre-image, a trapezoid kind of, and we are going to reflect this across our line. Y equals x. Close enough to get a visual. And then I'm going to rewrite these so that way I can notice how they flip. E prime is 1, negative 3. F prime is 3, negative 1. G prime is 2, 1. H prime is negative 1, negative 3. Okay, and graph them. We're almost done here. Alrighty, and that is our shape right there. our pre-image and our image in purple. And this last slide is just a concept summary of everything we learned. It's the sort of equations that you can use for reflection on x-axis, y-axis, and across y equals x.